For number 1, you had to describe whether this line was positive, negative, 0, undefined. This was a positive slope. Just going up the right or down to the left. And then you had to find the slope, which was 8/3. Questions on that first one? For the second one, we had to determine if these two lines were parallel, perpendicular, or neither. If you look at the slopes, they are negative reciprocals of each other, so they would be perpendicular. For number 3, you had to figure out what type of solution this was. As you start solving this, you should be able to see that you have different coefficients and different constants, so that would give you one solution. Or you could actually solve it, and you would also get one solution. Do we have any questions on number 3? On the back. For number 4, there were 2 ways you could have gone about doing this. One, using the point slope method that's not on here, but I could do that if you want to see that. The other one is if you start at the point 3, -3, we need a negative reciprocal slope perpendicular to the one that's given. So that new slope would be -4/3. So if I start at 3, -3, and I go up 4 to the left 3, I would end up at my y-axis. And that would give me the point I need to find my equation. Y equals -4/3x plus 1. For number 5, we have to solve this inequality first. Subtract 2x on both sides, divide everything by -2. Flip the sign because we're dividing by a negative. And then our inequality would be y is less than x minus 3. So we would start at -3. Our slope would be up 1 to the right 1. We would have a dash, or in my case, a dotted line. And it would be shaded below. Do we have any questions on those 2? So today we're going to do the last lesson in the review unit. So that means on Thursday, Monday, we'll be reviewing, you'll be taking your quiz, and then on Wednesday, you'll be taking your test. So everyone should have notes that look like this in front of them. We're just going to go through like 4 examples unless we want to see any others. And then you'll have time to practice on your own. Make sure you're following along, paying attention, writing things down. So we're going to start with example 1. We first need to see if there's a GCF, something that each of these things have in common that we could divide something out of. Does it have a GCF?
No.
Yes.
Okay. It doesn't, other than 1. Yes, it does. It's 1. I can say the GCF is 1, but if I divide 1 out, nothing would change. So if you said no, that's acceptable. There is 1, it's 1, but that wouldn't change anything.
So yes and.
Yes, that's why I said yes and no.
So I wasn't wrong.
Correct. You were not wrong. Okay. So now we're going to take the first number, or the first coefficient, and the last constant, multiply those together. And we're looking for 2 numbers that multiply to be 6, but add to be 5. Think of the factors of 6. Which of those would add to be 5? 2 and 3. What But this is different from the factoring we did last class, because now that we have these two numbers, we're going to rewrite this into 4 terms. Our first 2x squared is going to stay the same. Then you're going to put the two numbers you just found, but with x, so you're no longer going to have the 5x. And then you're going to put the last term.
That's all we're doing this for?
We're not done. Okay, then we're going to split the middle. And we're looking for, what do these first two have in common? 2 and x. So we're going to put 2 and x up front, and we're going to factor that out. But remember, when we factor things out, we're dividing, seeing what's left, but not actually dividing because it's still there. So 2x squared divided by 2x, what would that be?
1x plus 1.
It's 1x, and then if I divide 2x by 2x, that would be just 1. Correct. Then we're going to do the same thing for the second set of terms. What do these two have in common? 3. And this is positive, so I'm going to bring down that positive, make that positive 3. If I divide 3 out of both of those terms, what's left? 1 for which one? 1 for this one, yes?
X plus 1.
And x. If your insides are the same, and they should be, that becomes one of your factors. So x plus 1. And then everything on the outside becomes your second set of factors. 2x plus 3. If you wanted to double check that this worked, you could distribute it back out, and you should get the one that we originally started with. At the beginning? The 1 is what you're talking about, or in the group diff? So we're looking for what do these have in common, and these don't have anything in common except for 1. Do we have any other questions on this example before we continue? Moving on to example 3. Does this have a GCF?
Yes.
What is it?
2.
Can I divide 2 out of 5?
Oh, I thought you were talking about 6 and 4. So no.
So no. Well,
1.
1. But that wouldn't change anything. So then we can move forward with the next step. Multiply 6 and negative 4. So we're looking for two numbers that multiply to be negative 24 and add to be negative 5. Think about your factors. You may need to write down the factors to do a factor tree if that helps you. One of your numbers is going to be negative. What two factors will work?
Six and negative 8.
I heard two different sets of numbers. 6 and 4 wouldn't work. That wouldn't give me 5. But 8 and 3, and which one's negative?
Negative 8.
Negative 8, yeah.
Oh, I thought you
So then we can rewrite this into 4 terms. 6y squared stays the same. Does not matter the order in which you put the 8 and the 3, as long as you have y with them. And then put the negative 4 at the end. Then we're going to split the middle. What do these first two have in common?
2.
2 is right and something else y. And then if we divide out 2y, what's left?
Y.
3, y
3 and y, yes.
minus 4y.
Minus 4. What could we divide out of the last two?
1.
It's 1. If you can't divide out anything, you can always divide out a 1. But that wouldn't change anything. It would just be 3y minus 4. So then what would our two factors be?
3y minus 4 the first one. That one is 2y plus 1.
Does not matter the order in which you write these, as long as you don't put 3y plus 4 and 2y minus 1. Then you're good. Do you have any questions on that process, how we got the answer, before we continue? Caleb, did you have a question?
Yeah, I have a question. I'm just confused about the last step.
This one?
How's it all?
So this inside, we don't write twice. Think about this as it's part of two separate things, but we're combining it into one. So this becomes one of our factors, and then everything on the outside, the 2y and the plus 1, we put those together and make a factor.
What about the top one?
What about the top one?
Like, how do you break them?
Oh, we're looking for a GCF of these two, and what these two have in common is 2 and 1. And then we're looking for, if we divide this by 2y, what's left? And if we divide this by 2y, what's left? Mm-hmm. Yeah, did that answer your question? Rashad, did that clarify? Right, on the back. We're going to do number 12. So for number 12, does this have a GCF?
Yes.
Yes. What is that GCF? 2. We could divide 2 out of each of these. So we're going to go ahead and do that. Put a 2 on the outside. And if we divide everything by 2, what would be left? Plus x minus 1. Then the rest of our steps are the same. So then we're multiplying 6 and negative 1. This is for 12, not for 11. So two numbers that multiply to be negative 6 but add to be 1. Think of the factors of 6. One of them has to be negative. Which two numbers would work? Negative 2 and positive 3, that would work. If you find two factors and you're not sure, do that math. Multiply them, see if you get the negative. Add them, see if you get the number you're looking for. If you put negative 3 and positive 2, that would give you a negative 1, so that would not work.
We're supposed to get a negative 1.
In this case, we're supposed to get a positive 1.
Oh.
So for this, we can now rewrite this as 4 terms. So keep bringing down your 2, just drag it along. And we can rewrite this 6x squared minus 2x plus 3x plus minus 1. And then split the middle. And we're looking for what do 6x squared and negative 2x have in common? 2x. So we're going to bring down the 2 that we already factored out. And then write 2x. If we divide both of these terms by 2x, what would be left? 3x and minus 1. And what could we divide out of the last two numbers? 1. Which will leave us with just 3x minus 1. Then for our final answers, we're still bringing down that 2 from the beginning. And we have what's on the outside, 2x plus 1. And what's on the inside, 3x minus 1. So we have 3 answers instead of just 2. Before we do one more, do we have any questions on that process? Have we got that answer? This 3? So we're dividing 6x squared by 2x. So 6 divided by 2 would give us 3. X squared divided by x would give us x. That's how we got that 3x. Any other questions on that process? Have we got that answer?
The X thing, do you have a one?
Which one?
On the X thing. Why is there one?
This number in front of x here is 1. You don't see it. Let's do one more. Number 14. Does 14 have a PCM?
Yes.
Yes. What is the PCM?
2.
2. So if we divide 2 out of everything, what's left? X squared
8
minus 8x plus 1. And then we could multiply 16 and 1. We're looking for two numbers that multiply to be 16, but add to be negative 8. Think about your factors of 16. What numbers would work?
8, 4, 2.
All of those. So we're only looking for 2 numbers. So 8 and if I add 8 and 2, would that give me negative 8? 4 and 4 would work if they're both negative. So then I could rewrite this, bring down my 2, and I have 16x squared minus 4x plus 1. And then we could split the middle and bring down my 2. What did these first 2 have in common? X and 4. So 4 and x.
How did you? Oh, because
If we divide 4x out of both of these, what's left?
4x minus
4x minus 1. What could we divide out of the last 2? 1, but it would be negative. So if we divide out a negative 1, what would be left
2.
out of these last three?
Oh,
4x minus 1. And what would our final answers be?
x. What this is 4x. Minus 1. And 2.
Well, we have a 2 in
Yeah, like, 2 in the other one.
She wouldn't be inside the parentheses. Say that part again. Yeah, 2 would be on the outside like it is now. And 4x minus 1 again. So in this case, we have the same factor twice. So you could rewrite this as 2 times 4x minus 1 squared. Do we have any questions on how we got that process, the answer? Were there any that we skipped over that you want to see before I let you go ahead and practice on your own? So for the remainder of class, you have time to go and practice. I would say try as many of these as you feel like you need. Do some of the more regular ones that don't have a GCF or the GCF is 1. There's a bunch of those. Make sure you try some of the GCF ones. I know it starts here and then there are some more in the back on the practice page. So do some of both types. Make sure you're good with both types. Do a few of each type of example or as many as you feel like you need. Let us know if you need any help, want us to check over anything, have any questions. Does anyone have any questions on what we're doing for the rest of class? You all have this time to work. Let us know if you need our help. Hold on one second.